video, we're going to look into how to design a simple 2 to 4 binary decoder. So when we talk about a binary decoder, it has two rules. Number one is if my number of inputs equals n, my number of outputs equals 2 to the n. Number two is if it is an active high decoder, only one input should be equals to 1. The remaining should be equal to 0. Sorry, it is an active high. Now if it is an active high, right? If it is an active low, sorry, let me make it clear for you guys. If it is an active high, only one input equals 1. If it is an active low, only one input equals 0. The remaining should be equal to 1. So here have a simple truth table for a 2 to 4 active high decoder. So as I said, if my inputs is n equals 2, my 2 to the power of n is 4. So I have 2 rows, 2 columns for inputs, 4 columns for outputs. So as you see, for all my input cases 0, 0, 0, 1, 1, 0, 1, 1, only one of my output equals 1 as highlighted in yellow. So how do we complete this truth table? On the right, I have a simple additional column just to simplify our process. Let's look here. The first row has inputs which are 0, 0. So the decimal equivalent of 0, 0 is nothing but 0, write that. The second row has input 0, 1. Decimal equivalent of 0, 1 is 1. The third decimal equivalent of 1, 0 is 2. The last row decimal equivalent of 1, 1 is 3. So all what you need to do is for input 0, 0, write the respective output to 0 to be equal to 1. For instance, here my decimal equivalent is 0, so my output 0 equals 1. In the second row, my decimal equivalent is 1, so my second input D1 is equals to my second input D1 equals 1. The third row decimal equivalent is 2, so my third input D2 equals 1. The last row D decimal equivalent is 3, so my output D3 equals 1. So that is how you complete your 2 to 4 active high decoder truth table. Now let's derive this logic function. If you derive this logic function, my D3 is going to be nothing but D3 is A1 A0, D2 is A1 A0 bar, D1 is A1 bar A0, D0 is A1 bar A0 bar. So if you see, all the outputs have a product term which can be implemented by which logic gate? It is an AND gate. So I'm going to design 4 AND gates. For each of my output. My output D3, D2, D1, D0, and I have inputs. All of these are a product term of A or A1 bar and A0 or A1 bar, right? So I'm going to write A1 here, got straight line to have this line all the way down, implement it through an OR NOT gate, inverter, put it down. Similarly, I have A0. I'm going to put it down here. So my D3 is A1 times A0, right? My D3 becomes A1 times A0 here. D2 is A1 times A0 bar. D1 is A1 bar times A0. D0 is A1 bar times A0 bar. That is your simple 2 to 4 active high decoder. Now, how do we design a logic circuit for active low decoder? It's the same. As I said here, look for the truth table. My D3 is what? A1 times A0 whole bar. D2 is A1 times A0 bar whole bar. My D1 is A1 bar times A0 whole bar. D0 is A1 bar times A0 bar whole bar. So what we have is a complement of the product term. Complement of the product term. We have a product term. Complement can be obtained through design. So a complement of a product term could be obtained through a NAND gate. So for that reason, I'm going to design 4 NAND gates here. And I have my inputs A1 going all the way down here. And I have inputs A0 going down. So my D3 is A1 times A0 whole bar, right? So I'm going to take A1 times A0 whole bar. D1 is A1, sorry, D3, D2, D1, D0. So D2 is A1 times A0 bar, A1 times A0 bar. D1 is A1 bar times A0, A1 times A0, and D0 is A1 bar. My first input is A1 bar, the second input is A0 bar. A0 bar. So this is your 2 to 4 active low decoder. So one thing we do is whenever we use an active low or active high or any of these decoders, rather than drawing this entire logic circuit, we derive it in something like logic block. So I'm saying if I take all this, instead of designing all this, all what we do is put a simple logic block. On the left side, we write all the inputs, A1, A0. On the right side, we write all the outputs, which are D3, D2, D1, and D0. On the inside, we write the function here, 2 to 4 active low decoder. That is how you derive or design an active high or active low decoder.